Hello, my dear students. Last class I explained one problem with different water table location conditions. So let us continue with that problem. The problem is of a strip footing of 2 meter wide and carries a load intensity of 400 kilonewton per meter square. Here you are supposed to find the factor of safety with respect to the shear failure for the different cases. I have done water table is 4 meter below ground level and water table is just at the base of the footing. Now let us see how to find the water table if the water table is at 2.5 meter below the ground level. Okay, so this is the condition. So now water table is at a distance of 2.5 meter below the ground level. Okay, so 1.2 meter is the depth of the foundation. So 2.5 minus 1.2, this is 1.3 meter. Till here that is the ZW1 and this is below the base of the foundation ZW2. So now ZW2 is equal to 1.3. There is no effect of water table in this portion. So we can consider it as RW1 is equal to 1. Now you have to calculate what is RW2. RW2 is equal to half into 1 plus ZW2 divided by B. Okay, so now ZW2, that is this portion, is equal to 1.3 divided by 2 plus 1 into 0.5, 0.825. Okay, now here in this case, you can see that the breadth or width of the footing is greater than the depth of the water table. So you have to consider the water table effect here. How to do that? So there are two terms I have told. One term is surcharge term and the second term, and the other third term is the wedge term. Now here for the surcharge term, there is no effect of the water table because water table is located here. For this soil, there is no change in the conditions of the bulk density. It remains same. Okay, so gamma is equal to 16.8 kilonewton per meter cube. But for the wedge term, gamma will be taken as average unit weight of soil situated below the footing level, since the soil to the depth up to the depth B below the footing is partly above the water table and partly below the water table. Okay, so for this you have to calculate what is gamma average. This I have explained in the last video. You must be knowing that to calculate gamma average you have to use this formula. That is, gamma average is equal to 1 divided by B into gamma dW plus gamma dash into B minus dW, where dW is the depth of the water table below the base of the footing, that is this depth. So now let us calculate what is gamma average. So that is given by this formula. So here 1 into gamma, that is the first level, that is 16.8 into dW. dW is nothing but depth of the water table below the base of the footing. So that is this portion into 1.3 plus gamma dash, that is 19.5. It is given. Gamma dash is nothing but here that is saturated. Okay, I have written it is gamma dash, but it is gamma saturated. Okay. So that is into 19.5 into B minus dW. B is 2. 2 minus dW 1.3, that is equal to 0.7 divided by B. B is 2. So when you simplify this, you will get that is equal to 17.75 kilonewton per meter cube. This you can consider as gamma saturated. Okay, this is gamma saturated, not gamma dash. Gamma saturated. So once if you get what is gamma average, you can use that equation what I have solved in the first condition, I mean without considering the water table, that equation, that is QF is equal to 49.68 gamma into RW1 plus 42.4 into gamma average into RW2. It is this formula. Okay, this condition first we have calculated this. So substitute in this equation what is RW1 and what is RW2. So RW1 is equal to 1 here and gamma is equal to 16.8. Average now, gamma average is 17.75 into RW, that is RW2 is equal to 0.825. So when you substitute, you get this answer. So that is intensity, ultimate bearing capacity. Now you have to calculate what is factor of safety. Factor of safety is equal to ultimate is given 400. When you simplify this, you will get 3.64. Okay, like this you can calculate what is the factor of safety for the different locations of the table. Now let us take one more condition, that is case D, when the water table is 0.5 meter below the ground level. Now this is the ground level, this is the figure. Okay, so foundation is here, breadth 2 meter. Now water table is located at a distance of 0.5 meter. So 0.5 meter below the ground level. So it comes somewhere here. Okay. Now, so total this depth is what? That is 1.2 meter depth of the foundation. So total is 1.2 meter. 1.2 minus 0.5, that is equal to 0.7. Okay, that is G2 now. Now, how to calculate RW1 and RW2? RW1, to find RW1, you require ZW1. ZW1 is nothing but the distance from the ground level to the position of the water table. That is this point here. This is ZW1. Okay, this is ZW1. That is equal to now. This is ZW1, that is the position of the water table below the ground surface. So now use this equation. RW1 is equal to 0.5 of 1 plus ZW1 divided by D. That is equal to 0.5 into 1. ZW1, that is equal to now here this point, that is a distance, that is 0.5 divided by D, that is depth of the foundation is 1.2, total depth is 1.2, that is equal to 7.708. So this is RW1. Now you have to calculate what is RW2. RW2, that is what with respect to ZW2, that is always below the base of the foundation, that is this portion. Okay, but now that effect is not there because water table is located here only. So what you can consider, ZW2, that is equal to 0. So once if you substitute in this equation, that is same, both the formulas are same, RW2 and RW1, only this becomes ZW2. So this is now in this case ZW2 is equal to 0. So 0 plus 1 is 1. 1 into 0.5 is 0.5. So RW2 is equal to now 0.5 only. Okay, you understood now, because water table is located here only. So there is no effect of the water table below the foundation level. So that's why ZW2 equal to 0. Once ZW2 is equal to 0, RW2 also equal to 0.5. Now, how to consider gamma and gamma dash or saturated for the surcharge term and wedge term. For the wedge term, obviously the water table is here, so you have to consider gamma saturated. Gamma is equal to gamma saturated because water table is located here only, so the soil becomes wet. So once if it is wet, you have to consider gamma saturated, so that is equal to 19.5. Now for the surcharge term, means for the second term, what is that? What you have to consider here? You have to consider average unit weight of soil, means gamma average. Why? Because the soil situated above the base of the footing. Since the soil is located partly above the water table and partly below the water table. See, you can see here, water table is located here. So some soil is above the water table and some portion of the soil is below the water table. So you have to consider now gamma is equal to gamma average. But how to calculate gamma average? In this case, this is the formula. All these formulas I have given in the while explaining the lecture. Please go through that, you will understand. Okay, so now in this case, gamma average is given by this formula, that is gamma 1 d1 plus gamma 2 d2 divided by d1 plus d2. You understand, no, the difference between the previous problem and this problem. In the previous problem, the water table is here, okay, below the foundation level. So you can calculate gamma average using this formula. Okay, but if the water table is located in between this point, between the foundation and ground level, then you have to calculate gamma average using this formula. Okay, so substitute the same equation, gamma average equal to gamma 1 is equal to 16.8 into d1. d1 is 0.5 plus gamma 2, that is equal to gamma saturated value 19.5 into d2 0.7 divided by d1 plus d2. d1 is 0.5, d2 is 0.7. So you will get 18.38. So gamma average is equal to 18.38. Substitute that in the second term, that means in the wedge term. So substitute in the equation, you will get what is Q ultimate bearing capacity is equal to 1060 kilonewton per meter square. So you can calculate what is factor of safety, that is equal to QF divided by QA. You will get 2.65. Okay, I hope all of you understood. Just to see the difference between this condition C and D. Okay, in the condition C, the water table is here, so you calculated gamma average using this formula. But in this case, gamma average can be calculated by using this formula because water table is located at this point. Now, last condition, that is water table at the ground level. Now, water table is at this point only. This is the ground level, so water table is located here only. So now what happens, the entire soil becomes wet here. So both surcharge term also, wedge term also, you have to consider gamma saturated only because soil becomes wet, moisture, so gamma becomes gamma saturated. That is done. Now what about RW1 and RW2? RW1, here water table is this point only. So what is ZW1? So this is actually, the ZW1 is the position of the water table, distance from the ground level to the water table. But water table is now at the ground level only. So ZW1 is equal to 0. So this is the equation to calculate what is RW1, that is equal to half into 1 plus ZW1 divided by D. So now ZW1, it is equal to 0. So this term becomes 1. 1 into half, that is 0.5. RW1 is equal to 0.5. What about RW2? That is also same because water table is located here only. So there is no ZW2. So that is equal to 0. Once if you substitute ZW2 equal to 0, you get RW2 also equal to 0.5. Once if you know RW1, RW2, you can calculate what is the bearing capacity. In this case, once again I am telling, gamma is equal to gamma saturated because water table is at the ground level. So entire soil becomes wet here. So you have to take gamma is equal to gamma saturated. Okay, both in the surcharge term also and for the wedge term also. So this is the equation. QF is equal to 49.68 gamma sat rated into RW1 plus 42.5 into gamma saturated RW2. So substitute all the values, you get factor of safety. You have to calculate factor of safety, that is equal to ultimate bearing capacity divided by actual bearing capacity, that is equal to 2.24. Like this, you can calculate what is the safe bearing capacity for the different water table locations. I hope all of you understood. Please go through again and again, otherwise it is very difficult to understand. Okay, thank you.